Good morning, ladies and gentlemen. My name's George Adams, and I'm here on behalf of a group of us that are involved in a group called the Chartered Institute of Building Services Engineers Resilient Cities Special Interest Group. An idea formed about a couple of years ago to bring a number of people in the industry together, and some of my colleagues are here at the front and you'll hear from them later. And the idea of our group is to share knowledge, network amongst a number of experts. We have a steering group and we have a working group. And these three young ladies down here are working tremendously hard to make the group very successful. So I'd just like to say thank you to them in front of everybody. We are now hopefully forging links with lots of institutes and other organisations, but in particular we will be looking at how we're going to develop knowledge across the industry. And I also represent, in a way, another group which I touch on later on green infrastructure called the Trees and Design Action Group, which is something I'll touch on about how we bring green infrastructure into cities, and some of that will come out in my presentation here. So anyway, without any further ado, just to let you know, I'm not an academic, I'm a practicing engineer. I'm still designing engineering solutions for buildings in the built environment on a fairly regular basis. And some of my projects, just to give you an example, my role on the engineering, as the engineering manager for the Terminal 5 development, where we redesigned the engineering systems to attempt to save over 30% of the predicted energy costs. I am currently working on a project that I'm going to tell you about at the moment, which is all the tunnels under London for British Telecom, where we've just delivered some whole life savings. So that's sort of just a little snippet about me, sort of thing. Any questions so far? No, you're not allowed to yet, you haven't got time. So, just to start off with, my presentation is something that I've been deeply thinking about for about 3 or 4 years now, which is the subject of whole life thinking. Whole life thinking is a paper I wrote not so long ago called One Planet, One Environment, One Chance. The concept being that we do only have one planet to live on, we do have only one environment to share, and unfortunately we have one chance. That chance I will define as time. We have a limited amount of time to solve a number of very serious and growing problems. And I think whilst we talk about carbon as being a critical issue, we talk about global temperatures and so on, and energy and changing from fossil fuels, all of that is fine. But what we have to recognise is our most valuable asset at the moment is time to solve these problems. And I was very interested in some of the earlier presentations which touched on some things I'm going to touch on here, which is about trends. One of the trends that we've got at the moment is the issue of what I call the war on wealth. Now, I don't wish to be disrespectful to the very, very rich people in the world, but at the moment, about 10% of the population creates about 49%, as the chart shows, on our emissions. And this is one of the trends that is growing, that a smaller number of people is creating more and more of the emissions in the world. And as you'll see at the bottom there, that buildings are around about 50% of the issue when it comes to our global warming and in terms of greenhouse gas emissions. Now, some will say it's 39%, some will say it's 40% from buildings. My personal view is it's 50% if you look at it from a holistic point of view, not only involving the construction, the operation of the building, but also the decommissioning of the building as well. So, you know, anywhere between 39% and 50% actually does. It just tells us that the built environment is a very big contributor to a number of the world's difficulties. Behaviour is an issue. Why is behaviour an issue? Well, basically, at the end of the day, we are responsible for these issues, whether we like it or not. I know there are lots of debates about whether all of climate change is due to human intervention, but I think some of what we've seen a bit earlier today and a lot of the information that's around tells us very clearly that human intervention is the core cause of the climate change that we're seeing at the moment. But however, a lot of our trends, unfortunately, are not going in the right direction. For example, The latest BP energy report, which came out earlier this year, and it's a document I refer to a lot. It's a very authoritative document and very well researched. And BP are quite clear about this. They accept that there is an issue about climate change and things have to change. And they are showing us quite clearly that world energy is likely to go up by 2035 by another 41%, emissions by another 29%, difference there of course being an increase in the use of green energy and renewables. Population's going to go up to about 8.8 billion, natural resources. We are currently using about 50% more natural resources than the Earth can actually replenish. Now I wanted to just pause on that point because for me that's a very important point, because we talk a lot in the built environment about climate change, about global warming and about energy. What we have to recognise is that we actually have two really serious issues running in parallel. One is the consumption of natural resources, which is at an extremely high rate, and about 75% of natural resources we use goes into our cities currently. And of course we have running in parallel that with the problems with climate change. So we have two problems to solve, and cities and therefore buildings are at the heart of both those problems. Some of the other trends that are going on, if we go to the COP21, as was mentioned earlier, 21 years of trying, we're still not there. The result was better, but it's not good enough. And a 2-degree world is not a nice world to be in. Higher precipitation, Arctic ice melting, crop yields falling. And an interesting fact at the bottom there is some of the research shows that the hottest days in Europe is likely to rise by 6 degrees if we live in a world of 2 degrees of average global warming increase. Not a nice place to be, I would suggest. Okay, so moving on, I'm quite interested in stories from around the world. I collect stories around the world, and I've just got 2 or 3 here just to share with you. This particular one, this is about some work going on in Vietnam, where it is thought that Vietnam has already suffered an increase of half a degree, probably more now. 70% of the Mekong Delta is predicted that will suffer from flooding in the future. And local people don't know a lot about climate change science, but they do know what's happening to them. They know what's happening to their crops, they know what's happening to their rivers and their sea potential for flooding, and they're trying to do things. There's experiments going on amongst local communities of what is life going to look like for them in the future. And the little diagram there is a particular group of people that got together to try and establish what a new built environment for them, for their local community, including growing trees and their own crops, and how they would deal with climate change in the future. One of the stories that I do find interesting, which I'll just mention before going through this one, there's a village in Pakistan which relies on some particular environmental conditions to enable the crops to be watered at certain times of the year. And they found actually that because of climate change, the availability of the water wasn't becoming available at the right time to water their crops. And they are now looking at ways in which they can locally solve that problem. And this is where people are stepping up to the mark locally in their environments, where we in our lives in the West, and we are maybe some of the more favoured positions, we don't see some of these things going on. This particular issue here is for me one that's very serious. Areas of India, with the climate change that's going on at the moment, approximately 50,000 square metres could be suffering in the future, and that 3 feet of rise in sea could equate to 125 million people having to be dislodged from their current environments, their current living positions. And people, particularly women, are beginning to look at ways in which they can try and get their voices heard about their concerns. One that's much broader than that, of course, is air pollution. We hear now that about 7 million people a year are being killed by poor air quality, and that is mostly in our cities, and that's a real issue. And indeed, in being an issue, we find this right on our doorstep, because a good example of this last year, when Boris Johnson, the Mayor of London, made an announcement in the Evening Standard, please don't jog along Gracechurch Street in London. That's where my office is. and there's lots of people jogs up and down. So that was classified as the most polluted street in London. So these things are really on our doorstep too. But the global issue about air quality is becoming a major problem. One of the concerns I have is about policy on this issue. European policy, and the internal combustion engine was mentioned earlier today. One of the things that I find really difficult to understand is when we know these problems here, our policies take so long. The current European policy is that by the year 2050, the internal combustion engine will no longer exist in our cities. Well, that's a good 35 years away. I think it's a bit too late, really. So policy has to come into this issue somewhere, and I think needs to be a bit more urgent in certain areas. And if I could just go back to the point about COP21, you know, we know it's a difficult problem to get lots of countries around the world to agree on things, but 21 years down the line, we still don't have a robust policy on how we're going to deal with climate change around the world. Okay, moving on a bit, I mentioned trends. One of the points that I just wanted to mention here was that some studies been done, and basically for every year that we fail to tackle this issue of climate change could end up costing us $500 billion to cut carbon emissions later, i.e. the longer we leave it, the more expensive it gets. Well, that's natural because obviously the impacts can become bigger. But what reminds me here is what the work done by Sir Nicholas Stern back in 2006 and 2007. He made it very clear in his report that if we failed to invest at least 2%, his first report said 1%, but he subsequently changed it to 2% of world GDP into dealing with climate change, we could risk as much as 20% of our global GDP. Now that's obviously a pretty staggering thing to say, and at the time he was criticised for being rather harsh with his messages. Unfortunately, the way our trends are going on GDP growth, which I'll touch on in a minute, on energy consumption and so on, we are actually going in a direction he was worried about, and his figures are actually beginning to be proved correctly. Now, a little bit later, I'm just going to touch on why we don't learn from history. One of the things that intrigues me at the moment, and there's a slight divergence here, is about this issue of one planet living. There's a number of studies been done on this around the world, and some studies say this and some studies say that. One study, for example, says that in the UK, we actually need 2.9 planets. If everybody in the world consumed what we consume in the UK, we'd need 2.9 planets to live on. Of course, there are many countries in the world who don't need one planet to live on because they consume so little. The basic fact is we are living a trend that we cannot sustain. Nature is being damaged severely, and indeed we are using more than the Earth can supply. And we have to do something about that. That's about waste, it's about lifestyle, and it's about fairness and equality around the world. Because we also have to recognise that whilst the West, the richer countries, have to do something about their consumption and emissions, the poorer countries in the world have every right to live the same life standards that we do. And that is a dilemma that we have to manage. I did touch on a bit more about, I just touched on some of these subjects earlier. The key factor here that I wanted to mention is an interesting challenge because obviously our cities group, our Resilient Cities group, is focusing on cities. We have a challenge in cities because in our industry, in the built environment, we talk a lot about new cities and new buildings and new concepts and the wonderful dreams that we might have about cities of the future. The fact is that over 90% of what we have to deal with exists today, so we won't change that much. So what we see in our cities today, we have to make better. It's not going to be about building lots of new cities to move into. We have to make what we've got work better. And one of the interesting dilemmas here is that we now know that about 1.3 million people per week are moving into cities. We're heading for the direction where we're going to move on from about 65% of people living in cities to about 80% people living in cities, which means cities will consume more natural resources and will use more energy. However, I think cities are a massive opportunity. If we tackle the issue of cities and their climate change emissions and their consumption of natural resources, and the way in which we have transport in cities, the way we use energy, the way we can conserve energy, and I just want to dive off into deep energy refurbishment in a moment, then I think cities are a great opportunity, and I think we have the opportunity to deal with it. I think we have the technology. I think it's the economics that we have that's wrong, and I'll touch on economics in a bit. Deep energy refurbishment is going to be necessary. Deep energy refurbishment is a subject that isn't talked a lot about in our industry, but basically, by the definition of the International Energy Agency, that means a building that reduces its energy by about 70% would be considered to be a deep energy refurbished building. Can that be done? Yes, it can. There are studies around. I've particularly found studies in Australia, where they've taken existing multi-storey buildings, they've refurbished them, they've got the energy consumption down to that sort of level of reduction, and they've measured the quality of the air and the environment inside the building afterwards, and the improvements are there. So these things can be done, but of course it's the economics of doing it, the benefits of doing it. And one of the things I get very concerned about is the constant challenge we have in the built environment of the payback concept. It can only be done if the payback is quick enough. The payback is all about how much does it capital cost, how much is the savings going to be from an operational point of view. You divide one by the other, and if it comes to more than 2 years, we have a difficult challenge to convince the economists and the accountants to actually invest the money. Well, that's a false economy. Basically, it's a false economy because we're not counting the true cost of what a building does to the environment. The true cost is the cost of carbon emissions and the impact it has around the world. And I think we have to move to a different way of looking at economics from a whole life point of view. And that's where really whole life thinking starts to come into play to me. If we're going to build a building, let's remember, if it's not energy efficient as it could be, it has impacts elsewhere on our climate, on our society. And particularly, if we continue to build buildings, and a little short talk I'm going to do this afternoon on green infrastructure, if we continue to build buildings that are void of the understanding of the impact on society, then it creates a false economy again. Solar energy is an interesting subject. Some work around the world, particularly in America, is demonstrating that solar efficiency from solar PV could be heading towards 40 to 46% in different types of technology. And one wonders why we're not using more solar energy. And this is where I wanted to touch on history, some interesting points. For those of you that might not know, and Geoffrey Livermore is later going to talk to us about heat island effects, so I'm looking forward to that. Luke Howard was a kind of scientist back in the 1810s, and he did a study in London. And that study in London showed that London was about 3 degrees warmer than the rural area at that time. And he concluded that we had a difficulty in London. Now, at that time, of course, they didn't term it as the heat island effect. That was subsequently followed up by a study in Paris a few years later, which concluded exactly the same thing. So we already had some knowledge there that these were well put together scientific papers, and they were well known and well published. And so we already had an indication that something was wrong with our cities, something was different about our cities than our rural areas. In 1905, Einstein produced his first paper. Lots of people think it was E equals mc squared. Well, it wasn't. It was E equals hf, which is where we actually get the fundamentals of how we use solar energy. And that obviously Planck's constant comes into that, but his formula showed us the way for developing solar energy. And then along came Thomas Edison before he died in 1931, and actually said, basically, I'd put my money on solar energy, I wouldn't wait for fossil fuels, and he particularly mentioned coal and oil to run out. He hoped we wouldn't do that, and he hoped we would switch as soon as possible to the use of solar energy. And that was back in before 1931 when he died. Megis was there. And then we had Telstar, which is a saying I quite frequently use. We build but to tear down, most of our work and the resources squandered. And that is when we then come back to our use of natural resources. And even back then in 1943, Telstar was telling us, be careful, we're not using our resources efficiently or wisely. And I think we don't learn from these lessons. But the one that really intrigues me is a much more recent statement by Henry Kissinger, when he said, "It is not often that nations learn from the past, even rarer that they actually draw the correct conclusions from it." And I think that's a very true statement today, and I think this is all part of how we need to think differently. And that's what I'll come on to later. Sorry, I don't know how we're doing for time. Are we?
Halfway.
We're halfway. Well, that's going to be about right then. Okay. I've started doing some mapping of what whole life thinking might look like, and I started this a few months ago. And basically, the way I see it is that we as engineers and architects and so on, in the built environment, we design basically systems. If you look at building as a system of subsystems to house people and functions, it sits within another system, which is the interconnectivity the building has with its surroundings, whether that be rural surroundings or whether that be other buildings in an urban environment. But equally, it sits within the system of the environment and how that building affects the environment, and then that sits within the Earth's natural resources. And this is where I think our whole process of thinking in the future has to change. And I'm reminded at this point of a saying that, or a statement that Einstein came out with when he said, for humanity to survive, we have to learn to think in a very different way. I don't think we're at that point yet. I don't think we are thinking in a very different way, because I judge that by observation in the way we still build buildings, the way we still live as societies, the unfair distribution of wealth in the world, the fact that we've still got 20% of the world's population don't even have an electrical supply. Now these are serious issues that we have failed to address. So to me, the chart that I'm putting up there is starting the process of we need to think differently. 5 minutes is fine. The next message is very much about how we think about the future. So think about what we need for the future. And if you remember my point about economic models, we need to move to a more mature, a more sensible economic model that embraces all the issues that I've talked about. We need to think about that differently for the future. Now, do we actually do anything? Well, as I said, I'm a practicing engineer. So I thought I'd just throw in a couple of examples. This is a project I'm currently working on. It's part of my responsibility. It's 23 schools in Scotland, and my responsibility here is to make sure we deliver carbon energy savings. And the financial figures up there show you how much energy we've saved. We put in a very different energy management technology and an interactive maintenance process, and we remotely monitor the sites, and we tell the maintenance guys to go do things when things are not going right. Does it actually mean anything? Actually, yes, it does. Those figures up there are real figures. They are actually achieved figures over the last 3 years, and the benefit is that we've got about £100,000 of saving against some really robust benchmarks agreed with the client prior to setting off on this journey. So we are measured against benchmarks. And we've achieved we are achieving over the 25-year contract, we should be achieving about £2.8 million worth of energy savings and about 34,000 tonnes of carbon saving. That's all very well, but that's still a very narrow band, because that was a bolt-on after these fairly efficient buildings were put together in terms of design. We then came along and we were asked can we manage the buildings and can we save energy, which we've done, but none of the buildings have got solar panels on them. So we're now talking to the client about integrating solar panels. Another example, which is one that really excites me, is a project that I'm working on and I'm responsible for, which is, I can't sort of be too specific about locations because there is a security issue, but it's for British Telecom, and it's the tunnels under London. They have 23 kilometres of tunnels. They are all tube train sized tunnels. These are big tunnels where they run all their infrastructure, their copper cables and their fibre optics that allow all their communications and data to work. The tunnels were built back in the 1950s, believe it or not, to protect their cables from a possible nuclear strike on London. So quite where that thinking comes from, I don't know, so I can't explain that, but that's what it was. Anyway, we were called in 2 years ago because they were having a significant problem with air quality air movement, and lots of condensation. And I thought, this is an environmental problem. Long story cut short is that basically they could not afford a traditional full ventilation with lots of electric heating, because there's no gas or anything else on the site, to warm the air up and get rid of the moisture. So we had to come up with an injection ventilation system and a new control system that brings together all the different aspects so that we don't waste lots of cost on heating the air up. It's up, it's working, we've done the first commissioning results, so these are based upon some real figures. Basically, at the end of the day, we did have to address the payback. It's 5.7 years. But basically, £2.7 million worth of predicted energy savings and about 42% reduction in carbon emissions. That's all right, it's okay. Glad about that. Very pleased client, things are working well, the condensation's largely disappeared. The interesting thing about this was the environmental issue, was the amount of condensation in the tunnels that was being caused was actually damaging the tunnels, which is an issue. So just through a couple of real examples in there of where we're actually sort of doing real sort of whole life studies and improvements, but again, still fairly narrow in its broader aspects, because, you know, where did we buy the fan from? Yes, it was all the right legal requirements of where we bought all the equipment from. But unfortunately, the equipment we had to strip out, we couldn't reuse it because it was so under-designed. And that's sad. And I think that's one of the problems as engineers we have to get to grips with, is how can we design things into buildings that can be reused? This is about recycling and not throwing things away and putting new stuff in. And then I think we're nearly there. The next map that I'm looking at is how we pull all this together in terms of human behaviour, in terms of recycling, in terms of energy use, in terms of how we damage the environment and how we create pollution. This is a map that I'm currently working on. I'm doing some further work on this to try and establish how this is actually going to work and how it could inform the people in the built environment as to think differently. The message here was, come on guys and girls, we need to think differently. Last but not least, that all comes down to basically some key figures. 1% of humanity owns 50% of the global wealth. I think this is a massive issue for us around the world. 62 billionaires, a study from Oxfam recently, only 62 people, billionaires, own more wealth than 3.4 billion people in the world. And 10% of the wealthiest societies create 50% of our environmental issues. This is an unfairness issue. It is an issue that we can't run away from. We have to tackle it. And basically, if we don't get economics, society, and buildings working better together, I don't see how we can go forward. And that's my basis for saying, basically, is whole life thinking a nice to have, or is it essential? That's my question. Okay, thank you.